The thing about the t-test is that it ignores individual variability. Now, that is by design. With the t-test, we want to know whether the average of this group is different from the average of this group. But what if the individual variability is actually meaningful and we want to relate the variability here to the variability here? So for example, let's imagine we go out and we find a bunch of identical twins. So then we can label all the individuals in these two groups. So 1 and 1, this is a pair of twins. 2 and 2, this is a pair of twins. And up to 9 and 9 is a pair of twins. So then what we do is ask this group here, what is your general feeling about death metal music? And then we go up to this group and we say, what is your feeling about death metal music? How much do you like listening to death metal? And then we can see whether there is a genetic component to liking death metal music. Because if there is, then what this twin likes, this twin is also going to like. So we can visualize that here by putting the answer to twin number 1, how much do you like death metal, on this axis, and the answer from number 2, how much do you like death metal, on this axis. And then we can plot. So this number here, of course, this data point here is actually data from 2 different individuals. They're twins, but they're 2 different individuals and they share one single data point because we plot how much twin 1 likes death metal by how much twin 2 likes death metal. So you can see we're actually showing a lot of data on this one graph. Now it's also pretty clear that there is a trend in these data. So when twin 1 likes death metal music more, then twin 2 tends to like death metal music more. So, maybe there's a genetic component to liking death metal. On the other hand, most twins grow up in the same household, so maybe there's just a family association. Anyway, this is the idea of a correlation analysis. With a correlation analysis, we take 2 sets of data points, 2 variables that are somehow related to each other, and we can plot them on a plot that looks like this. It's called a scatter plot or a dot plot. And then we want to find the trend line that's going through them. And that trend line measures the strength of the relationship between these 2 variables, in this case, these 2 twins and their preferences for death metal music. So a correlation analysis gives us a correlation coefficient. And the correlation coefficient is one number for each data set. It varies between -1 and +1. A correlation of -1 means an inverse relationship. A correlation of 0 means no relationship. And a correlation of +1 means a perfect positive relationship. I'm going to show you pictures on the next slide of what these inverse or negative, 0, and positive relationships look like. Now, a correlation coefficient is by itself just a number. We cannot directly evaluate the statistical significance of a correlation only by looking at the coefficient. Instead, we need to compute a p-value that's interpreted in exactly the same way as I explained p-values in the previous section. Okay, so here you see an example of a positive correlation. So when one variable goes up, the other variable also goes up. Now this is not a perfect correlation because there's a little bit of variability. Maybe the correlation coefficient here would be, maybe something like 0.9, 0.85, somewhere around there. Here's an example of a negative correlation. A negative correlation, or an inverse correlation, means that when one variable goes up, the other variable goes down. You can imagine that each of these dots is a person, and what we're plotting here is the temperature outside as a function of how much money people are spending buying winter coats. So as it gets warmer out, people are spending less money on winter coats. Or we can interpret it the other way. When it gets colder, people are spending more money on winter coats. Okay, so that's a negative correlation. Here's an example of a 0 correlation. So 0 correlation data tend to just look like a big cloud. There isn't any clear relationship between one variable and the other variable. Now, one thing to note about the correlation is that it is a linear relationship, which means it only identifies lines that go through the data like this. So you can have a situation like this where there is a real relationship between the the data between the variables x and y. However, the correlation coefficient is actually going to be 0, and that's because this is a nonlinear relationship. You cannot draw a straight line. You have to draw a curved line. So when you have a nonlinear relationship, then a correlation is not necessarily going to be a good measure of the relationship between the two variables.